Hello, my precious friends. I really hope that you are doing great. Welcome to today's class. It is our 9th lesson on the third topic of Form 4, which is called floating and sinking. As usual, let me commence by giving the quote of the day, which states that we should all strive to be human and not just human beings. We shall discuss that quote at the end of our class today. So let's start by looking at an example which reads that a simple hydrometer is set up with a test tube of mass 10 grams and length 12 centimeters with a flat base and partly filled with lead shots. So the test tube has a uniform cross-sectional area of 2 square centimeters and 10 centimeters of its length is underwater as shown in this particular diagram. So part A, we are told that taking the density of water to be 1,000 kilogram per cubic meter, calculate the mass of the lead shots in the test tube. So this is the setup. So for us to find the mass of the lead in the that is of the lead shots in that particular test tube, we shall first of all, because this particular test tube is floating in water, it simply means that the upward and the downward forces are at balance. Of course, the downward force will be the weight of the test tube plus the weight of the lead shots. Then the upward force will just be the upthrust force, which must be equal to the weight of the fluid displaced, courtesy of the Archimedes principle. So they want us to find the mass of the lead shots. So we'll start by finding the weight of the lead shots, because we know that weight is equals to mg. Once we get the weight, we'll be in a position to find the mass from the formula weight is equals to mass multiplied by gravity. So the weight of the test tube plus the lead shots, which represents the sum of the downward forces. So the downward forces will be the force due to the weight of the test tube plus the weight of the lead shots that are within that particular test tube. Remember that weight will always act downward. So therefore, total downward forces will be the weight of the test tube plus the weight of the lead shots that are placed within the test tube to keep it floating upright. Then the upward force, of course, will only be the upthrust force. From Archimedes' principle, which is stated that when a body is partially or totally immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. It simply means that the upthrust will be equal to the weight of the fluid that is displaced. In this case, the fluid being displaced, of course, is water. Therefore, upthrust is equal to the weight of the water that will be displaced, which is the only upward force. So the weight of the test tube plus the weight of the lead shot, I'll simply separate the two. Weight of the test tube will be given by mass times gravity, because we are given the mass of the test tube to be 10 grams. Then the weight of the lead shots, we don't have the weight of the lead shots, but we know that if we get the weight of the lead shots, we'll be in a position to find the mass of the lead shot, which is what the question wants us to find. Then weight of the water displaced or the fluid displaced can be given by rho Vg, that is density of the water displaced times volume of the water displaced multiplied by gravity. Therefore, the weight of the test tube, which is mg, so the mass of the test tube was 10 grams. Therefore, when we talk of mg, if I convert the 10 grams into SI unit, which are the kilogram, we know that 1,000 grams is equals to 1 kilogram. What about 10 grams? So I'll have 10 grams of 1,000 grams times 1 kilogram. So that is to convert it into kilogram. Then gravity is always 10 Newton per kilogram. So this is the weight of the test tube alone. Then plus the weight of the lead shots. So it will just be W lead shot is equals to the weight of the water displaced, which is equals to upthrust, will be rho Vg. So density of the water displaced. So of course, the density of water we are given as 1,000 kilogram per cubic meter. That is the density of fresh water. Then times the volume of the water displaced. So because we are not given the volume of the water displaced, but we know that the volume of the water displaced will be equal to the volume of the test tube that is submerged within this particular water. Remember, volume is the amount of space occupied by a body. Therefore, the space that this particular test tube occupies in the water will be equal to the volume of the water that has been displaced in order to provide the space that this particular test tube is occupying in this particular water. Therefore, the volume of the water displaced will be equal to the volume of the test tube that is immersed in the water. So the only part of this particular test tube that is immersed in water is up to a height of or a length of 10 centimeters. So the volume of the test tube that is immersed in water will be equal to the volume of the water displaced. Then of course the test tube is in cylindrical shape because it has a circular base. Then we know that volume of a cylinder can be given by pi r squared h, which can also be given by cross-sectional area times the height, because we are already given the cross-sectional area of the test tube, which of course is in cylindrical shape. So the volume of the water displaced will be equal to the volume of the test tube that is submerged within that particular water. Then volume is cross-sectional area times height. We are given that the cross-sectional area of the test tube was 2 square centimeters, so we are given here, but we know that the SI unit of area is a square meter, so I'll convert the 2 square centimeters into meter. We know that 10,000 square centimeter, that is square centimeter, is equals to 1 square meter. What about 2 square centimeter? So that will be 2 square centimeter over 10,000 square centimeters times 1 square meter. Then so that will be the cross-sectional area in meters, then of course times the height. So the height will use the height of the test tube that is submerged in the water, because it is only this part of the test tube that is within the water that will be equal to the volume of the water that will be displaced. So the height that is submerged within the water of that particular test tube you are given as 10 centimeters. Again, the SI unit of length is meters, so we know that 100 centimeters is equals to 1 meter. What about 10 centimeters? So that will be 10 over 100, that is to convert it into meters, so that the volume will be in cubic meter. Then gravity, of course, is 10 Newton per kilogram. So if I take 10 over 1000 times 10, you'll obtain 0.1 plus the weight of the lead shots, which is W lead shots, is equals to the density, which is 1000. If you take 2 over 10,000 multiplied by 10 over 100, you'll obtain 0.00002, that is cubic meters. Then of course times 10. So if you take 1000 times 0.00002 multiplied by 10, you'll obtain 0.2 Newton as the upthrust or the weight of the water that was displaced as a result of immersing up to 10 centimeters of this particular test tube. So because the total downward force was the weight of the test tube plus the weight of the lead shot, so we'll simply say that 0.1, which is the weight of the test tube plus the weight of the lead shots, must be equal to the upthrust, because the body is floating, therefore the system is in equilibrium, so the upward forces must be equal to the downward force. The downward force, we have said, is the weight of the test tube plus the weight of the lead shots, because weight acts downward. Then the only upward force is the upthrust, which is equals to the weight of the water displaced, which is equals to 0.2 Newton. So if I make weight of the lead shots to be subject of the formula, I'll simply take 0.1 towards the right hand side so that it becomes a negative. So weight of the lead shots will be equal to 0.2 minus 0.1, which gives me 0.1 Newton. So this is the weight of the lead shots. But the question wants us to find the mass of the lead shots within the tube. But once we have the weight, we know that weight is equals to mass times gravity. Therefore, if I make mass subject of the formula, in that formula that W is equals to mg, the mass of the lead shots will be equal to the weight of the lead shots divided by gravity. So weight of the lead shots, of course, is 0.1 Newton. Then gravity is 10 Newton per kilogram. So 0.1 over 10, you'll obtain the mass of the lead shots to be 0.01 kilogram, which can be converted to grams to give us 10 grams. Then part B, they want us to find the mass of the lead shots to be added if it has to displace an equal volume of a liquid of density 1.25 gram per cubic centimeter. So we are told that it has to displace an equal volume. Therefore, the volume of the water displaced in the first part will be equal to the volume of the liquid displaced in the second part. So in order for us to find the mass of the lead shots to be added, again we'll simply equate the sum of the upward forces and the downward forces. So because we are using a different liquid that is apart from the water, it simply means that the upthrust to be offered will also change, because remember, each liquid has its own upthrust value. That is, each liquid offers a different value of upthrust. So we'll be forced to calculate a new value of the upthrust due to this particular liquid. Then we know that upthrust will be equal to the weight of the liquid that will be displaced. so which is equals to rho Vg. So density of the liquid displaced times volume of the liquid displaced multiplied by gravity. So the weight of the liquid displaced will be equal to the density of the new liquid which is being displaced is 1.25 gram per cubic centimeter. But we know that 1,000 kilogram per cubic meter is equals to 1 gram per cubic centimeter. What about 1.25 gram per cubic centimeter? So that will be over 1 gram per cubic centimeter multiplied by 1,000 kilogram per cubic meter. So the multiplication by 1,000 is simply to convert the 1.25 gram per cubic centimeter into the SI unit of density, which are the kilogram per cubic meter. Then the volume of the liquid displaced, we are told that the mass of the lead shot to be added if it has to displace an equal volume of the liquid. So that simply means that the volume of the liquid displaced is equal to the volume of the liquid that was displaced in part A. So the volume of the liquid that was displaced was actually 0.0002 cubic meter. Therefore, the volume of the liquid displaced is the same mass that in part A, which is 0.00002 cubic meter. So we are using the same volume because the question has told us that it has to displace an equal volume of the liquid. So the volume of the water displaced will be equal to the volume of the new liquid that will be displaced. Then of course multiply by gravity, which is 10. So if you take 1.25 times 1,000 times 0.0002 cubic meter times 10, you'll obtain the weight of the liquid displaced to be 0.25 Newton, of course, which is equals to the new upthrust. Again, we know that the sum of upward forces and downward forces must be equal. Therefore, the sum of downward forces will simply be equal to the weight of the test tube plus the lead shots. That is the initial weight of the lead of the test tube plus the lead shots plus the new weight of the added lead shots. Remember, we are told that the mass of the lead shots to be added. So apart from the lead shots that were already there are other lead shots that have been added in this particular test tube. Therefore, the total downward force will be equal to the weight of the test tube plus the weight of the lead shots plus the weight of the other lead shots that have been added. So the weight of the test tube plus the lead shots plus the other added lead shots must give us the new upthrust force, which is 0.25 Newton. Remember, upthrust is the upward force. Then the sum of these weights will be the downward forces. So the weight of the test tube plus the lead shots, that is initially, it was, the weight of the test tube initially was, we had already computed it as 0.1 Newton. Then the weight of the test tube was 0.1 Newton also. So the weight of the test tube plus the lead shot was 0.1 Newton plus 0.1 Newton. Then plus the weight of the added lead shots, which is W added lead shots. So for us to find the mass of the lead shots that have been added, we need first of all to find the weight of the lead shots that have been added. So if you take 0.1 plus 0.1, you'll obtain 0.2 Newton, then plus the weight of the added lead shots, which must give us the upthrust, which is 0.25 Newton. So if I make weight of the lead shot subject of the formula, I'll simply take the 0.2 towards the right hand side, so that the weight of the lead shots will be 0.25 Newton minus 0.2 Newton, which gives us 0.05 Newton. So this is the weight of the added lead shots. Therefore, we know that weight is equals to mg. Therefore, the mass of the added lead shots will be equal to the weight of the added lead shots divided by the gravity. And the weight of the added lead shots was 0.05 Newton divided by gravity, which is 10. So if you take 0.05 divided by 10, you'll obtain 0.005 kilogram, or which can also be given as 5 grams. So that is the mass of the lead shots that were to be added if it has to displace an equal volume of the liquid of density 1.25 gram per cubic centimeter. So the key thing here is simply to equate the upward forces and the downward forces. Then you should also always remember that in most cases the upward force will just be the upthrust force due to that particular liquid. Next, we look at our second example, which reads that the figure below shows a test tube of cross-sectional area 2 square centimeters partially filled with lead shot floating vertically in water. Determine part A, the volume of the water that was displaced. So it is important to note that volume is just the amount of space occupied by a body. Therefore, the volume of the water that will be displaced will be equal to the volume of the test tube that is already submerged in the water. Therefore, the volume of the test tube that is submerged in the water, which is up to a height of 5 centimeters, will be equal to the volume of the water that will be displaced. Therefore, the volume of the water displaced is equal to the volume of the test tube that is already immersed in water. Then because we are already given the cross-sectional area of that particular test tube, we are also given the height of the test tube that is already submerged in water, and we know that volume can be given by cross-sectional area multiplied by the height. So the volume will be cross-sectional area of the test tube multiplied by the height of the test tube that is already immersed in water. Therefore, the cross-sectional area we are given as 2 square centimeters, so we convert into square meter. We know that 10,000 square centimeters is equals to 1 square meter. What about 2 square centimeters? So that will be 2 square centimeter over 10,000 square centimeter times 1 square meter multiplied by the height of the test tube that is already immersed in water. We are given as 5 centimeters. So to convert into SI unit of length, which are the meters, that is, I'll simply take 5 centimeters over 100 times 1 meter. So if you take 2 over 10,000 multiplied by 5 over 100, you'll obtain 0.00001 cubic meter as the volume of the test tube that is already submerged in water, which is equal to the volume of the water that will be displaced as a result of immersing that particular test tube up to a height of 5 centimeters in that particular water. Then Roman 2, they want us to find the weight of the water displaced. Now remember, the weight of the water displaced must be equal to the upthrust, courtesy of the Archimedes principle, which stated that when a body is partially or totally immersed in a fluid, it must displace. That is, when a body is partially or totally immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. Therefore, the upthrust must be equal to the weight of the water that will be displaced. And we know that upthrust can be given by rho Vg. So the weight of the water displaced will also be given by rho Vg. That is the density of the water displaced times volume of water displaced multiplied by gravity. So the density of the water displaced, of course, we know that the density of water is usually 1,000 kilogram per cubic meter. That is density of fresh water. The volume of the water displaced, we have already computed it in part A, multiplied by gravity, which is usually 10 Newton per kilogram. So you take 1,000 times 0.00001 multiplied by 10, you will obtain the weight of the water displaced, which is equal to the upthrust, to be 0.1 Newton. Then part B, we are told that state the combined weight of the test tube and the lead shots. We have just said that provided that a body is floating, it simply means that the sum of upward forces and the downward forces are in balance. So of course the downward force will be due to the weight of the test tube plus the weight of the lead shots within that particular test tube. Then the only upward force will be the upthrust, which is equal to the weight of the water displaced. Therefore, at equilibrium, or when the body is floating vertically, the weight of the test tube plus the lead shot, which is the sum of the downward forces because the weight acts downward, must be equal to the sum of the upward forces, which is the upthrust, which is equal to the weight of the water displaced. Therefore, the weight of the test tube plus the lead shots will be equal to the weight of the water displaced, which is equal to the upthrust, which is equal to 0.1 Newton, because we have already computed it up here in part A, Roman 2. So this is the density, that is the weight of the test tube plus the lead shots. Then part C, we are told that determine the length of the test tube that will be submerged in a liquid of density 800 kilogram per cubic meter. So again, if you are immersing it in a different liquid, the only thing that will change is actually the upthrust, because different liquids will offer different forces of upthrust. So we must look for the upthrust offered by this particular liquid. So we know that that is from the law of flotation, that a floating body displaces its own weight of the fluid in which it floats. So the weight of the test tube plus the lead shots must be equal to the weight of the liquid that will be displaced. That is the weight of the new liquid that will actually be displaced. That is courtesy of the law of flotation, that provided a body is floating, then it must displace its own weight of the fluid in which it floats. So the weight of the test tube plus the lead shots, of course, has not changed, will just be still 0.1 Newton. Then the weight of the liquid displaced, which is equal to the upthrust, will simply take rho Vg, that is density of the liquid displaced times volume of the liquid displaced multiplied by gravity. So 0.1 Newton, which is the total downward force, must be equal to the total upward force, which is the upthrust, which is rho Vg. So density of the liquid displaced. We are now talking of another liquid which has a density of 800 kilogram per cubic meter. So the density is 800 kilogram per cubic meter times the volume of the new liquid displaced, which is an unknown, multiplied by gravity, which is 10. So if I make volume of the new liquid displaced subject of the formula, I'll simply divide both sides by 800 times 10, which is actually 8,000. So the volume of the liquid displaced will be 0.1 Newton divided by 8,000. That is 8,000. So this will give me the volume of the liquid displaced to be 0.1 over 8,000. You'll obtain 0.0000125 cubic meter. So this is the volume of the liquid that was displaced. And remember, we are told to determine the length of the test tube that will be submerged. So we know that the volume of the liquid displaced must be equal to the volume of the test tube that is submerged within that particular liquid. Therefore, the volume of the liquid displaced, which you have already computed it, must be equal to the volume of the liquid, that is the volume of the test tube that is immersed within that particular liquid. So the volume can be given by cross-sectional area times height, because we are given the cross-sectional area of the test tube to be 2 centimeter squared. If I want to find the height, which is equals to the length of the test tube that will be submerged in that particular liquid, so I'll simply say that volume is equals to cross-sectional area times height. Therefore, height, which is equals to the length, in this particular case, the length of the test tube, will be equal to volume divided by the cross-sectional area of the test tube. So the volume of the liquid displaced, which is equals to the volume of the test tube that is immersed within or submerged within that particular test tube, is, of course, we have already computed it up here at 0.0000125 cubic meter. Then the cross-sectional area of the test tube remains to be the same, which is 2 square centimeters. To convert into square meter, I'll simply divide it by 10,000. So if I take 0.0000125 cubic meter divided by 2 divided by 10,000 square centimeters, that is square meters, I'll simply obtain the length, which is equals to the height, which is equals to 0.0625 meters, which when expressed in centimeters, we shall obtain 6.25 centimeters. So that is the length of the test tube that will be submerged in a liquid of density 800 kilogram per cubic meter. Again, the thing that we are using, the sum of upward forces must be equal to downward forces. So the downward force is simply the total weight acting down, then the upward forces is the upthrust, which is equals to the weight of the fluid displaced. Lastly, I have an exercise that I recommend you should try at your own free time to gauge the understanding of the concepts that you have just learned. Of course, if you have any challenges in handling any of the questions, feel free to drop a comment specifying the question that you need help in, and as usual, I'm always here to try and help where possible. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that we should all strive to be human and not just human beings. So the quote is reminding us that our core business as human beings is to make the world a better place for living by conserving our environment, encouraging others to grow and become better versions of themselves, creating a conducive environment for other creatures to grow and fulfill their potential. And lastly, recall that there is a big difference between human being and being human. How I wish you understood the difference and acted according to the latter meaning. That is the meaning of being human. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.